So the math itself is not that difficult. What do I mean by that? Just the three laws, right? Like, here, let's do a quick thing here. If you have y to the minus 3n here, and let's say you have y to the 2n here, what does this give? I have two y's, I just want one. You're going to want to bring this down here because that'll give you a positive exponent. If you bring that guy down, what do we get here? How many n's? No?
5?
Yeah, 5, right? That's it. What is 2n times 2n?
Is it just 2n squared?
So you want to multiply the number with the number, the letter with the letter. What's 2 times 2? Well, that's a 4.
4?
That's a 4n squared, okay?
Okay.
So this is as hard as it gets in terms of the actual mathematical operations. But it's a little bit more difficult than that because there's going to be a lot of different things involved. Let's see. This one is looking pretty easy, but look at A. It's literally a one-step answer. Like what's the power of -7? There's multiple things. We're going to combine them into one -7. This would be the first law. No, it's just this law, right? XA times XB, and then because they have the same base, they have the same base here. You're allowed to add the exponents up.
Oh, okay.
So what's the number in the exponent?
-1.
Yeah, that's it, right? That is it. And what you can do is the -1, because we don't usually like negative exponents, so we're going to toss the base -7 downstairs. This will make the exponent positive. Cool? Is it hard?
No,
It's a one-step answer, literally one-step answer. Let's look at B. Oh, sorry, the other one here. What's the first thing you do here?
you could open the brackets.
Yeah. So how many 4s do you get if you open the first bracket up?
4 to the power of -18.
Right. What about in the denominator?
You just get 4 to the power of -32.
Right. And now we want to combine them. If you look at it in the numerator, how many 4s do you get in the numerator if you combine those two?
4 to the power of -28.
Right, and then you have the 32 down. Do you bring the 28 down or the 32 up?
The 32 up.
Yeah, so what's the final answer? How many 4s? So this minus, if you bring this up, becomes a plus, right? The sign always
So 4
flips.
to the power of 4.
Yeah, and that's it. Just a couple of multiplications and additions. That's pretty much gonna be the whole unit. Let's look at something similar, but at the same time different. We're gonna turn exponents, right? Exponents into radicals. Radicals just means like a root form, square root form. How does it work? If you have the square root of x, this means it's x to the power of 1 over 2. If you have the square root of x squared, it's going to be x to the power of 2 over 2. Because square root means there's an invisible 2 here on the outside, and that's going to go in the denominator. For example, square root of x cubed, this is going to be x to the power of 3 over 2. Cube root of x squared, this will be, whatever the root is, this always goes in the denominator, x to the power of 2 over 3. if you have the cube root of x, let's just say the cube root of x, this is going to become x to the power of 1 over 3. You see that?
Mm-hmm.
The radical, the root in the radical always goes in the denominator, okay? Using this logic, what is x6 square rooted?
X to the power of 6 over 2.
Yeah, which is x3. What about x10, y10 square root? No, do them individually. So the root, just like how if you're doing 3 times a squared plus b squared, this 3 applies to everything in there. Same thing here. The square root applies to everything inside. So you would get x to the 10 over 2 and y to the 10 over 2, which gives you
Which is just
x5.
5.
Yeah, there you go. That's it.
Okay.
Okay. So they just want us to rewrite it in the other form. Look at A, it's in the radical form right now. We just did like 5 questions like these. This root here, this is gonna go in the denominator. So this simply becomes x to the 7 over 3, and you're done.
Mm-hmm.
B, we need to rewrite this in the root form. What does this become? We wanna write it like this, like how A was. This denominator becomes the root, and the numerator stays inside, like that. Okay?
Okay.
What about C? If I want to write this in the exponent form,
You get p to the power of 11 over 2.
yeah. What about D? Well, D is a little bit tricky. You need to rewrite 1.25 as a fraction first. What could it be? Something over something is 1.25.
Well, as a mixed number, it would be 1 and 1 over 4.
That's right. And then you can just change this into an improper fraction. What do you get?
5 over 4.
Yeah, so this is the same thing as m to the 5 over 4. And if you want to rewrite this in the radical form, what do we get?
M to the power of 5 and then root of 4.
Yeah, like that. And you're done. Okay, all of these are almost 1-2 step questions. But it does get a little more difficult. Let's do these guys. I mean, again, it's not, to be honest, I don't think it's that. The math is very simple. Like here, this one, we're going to use the special rule for negative exponents. If you have a fraction to a negative exponent, what you do is you turn it upside down. The exponent becomes positive, right?
Mm-hmm.
So you have 2 over 5 to the negative 3. You flip it upside down, becomes 5 over 2 to the power 3. This cubed applies to both the 5 and both the 2. What is 5 cubed?
It's 125.
Yeah, what about 2 cubed?
8.
There you go, and you're done. Let's look at D. What's the cube root of negative 27? No,
It's 3.
negative 3. Okay. Cube root of negative 27 is negative 3. Cube root of 27 would be 3. So we have negative 3 to the power of 4. Is that going to be a positive number or a negative number?
Positive.
Yeah, it's 81 if you just put that in a calculator. And that's pretty much it. It's a two-step thing. Same idea here. For b, we're gonna flip it upside down to make the exponent positive. And we know negative 0.5 is just 1 over 2, right?
Mm-hmm.
What's 225 to the power of 1 over 2? That's just a to the power of 1 over 2 just means the square root. Like that. What's the square root of 225? You can put it in a calculator if you have one.
It's 15.
Right. And then the square root of 16 is just a 4, and you're done. Cool?
Mm-hmm.
Let's look at E. The fifth root of negative 32. You can also put that in a calculator. What you can do is type it out like this. Negative 32 to the power of 1 divided by 5. Maybe you need to put this in a bracket.
It's 2.
It's negative 2, right?
Mm-hmm.
It's negative 2. Similarly, the sixth root of 64 is positive 2. Like that to the power of 5. This would be negative 2 times positive 32. So the answer is negative 64. Okay,
Okay.
good so far on this topic?
Mm-hmm.
And that's the thing, right? If you're not comfortable with it, you just gotta, to be comfortable with it, you just gotta go into the deep end and keep doing these like little problems. And eventually you'll see that it's actually not that difficult. So here we have a negative exponent. Always toss the negative exponent downstairs. It's gonna become positive. What's 0.25 as a fraction?
1 over 4.
Right, so we're looking for the fourth root of 81. And the third root of negative 125, what is that? If you're gonna plug it in a calculator, you can plug it in like this. Negative 125 to the power of 1 divided by 3.
It's 5.
Negative 5, right?
Mm-hmm.
Can't be positive because if you multiply positive 5 3 times, you will not get a negative number. It has to be negative. And the fourth root of 81, what is that?
It's 3.
Yes, so you have 1 over 3 times negative 5, and then this is going to be 1 over negative 15. Okay?
Mm-hmm.
That's the final answer, and that's it. It's easy as that. F. We're gonna work our way from always from the inside to the outside. So forget about this 6 for now. What is negative 2 cubed and then squared?
Do you get positive 64?
Yeah, but you don't have to turn it into that. You can just rewrite it as negative 2 to the power 6, right?
Mm-hmm.
And when you write this in the exponent form, it's going to be negative 2 to the power 6 over 6. these two cancels out, and then the final answer will just be -2.
Okay.
Easy enough?
Mm-hmm.
Um, let's try doing some of these guys. Let's look at D. What would be the first thing to do here? What do you attack? Hmm, attack this bracket, and you can attack this bracket. Okay? So we
Mm-hmm.
have the fourth root of x to the -16. What about this x? How many do we have now?
-36.
-36. And on the bottom, what's 4 times -11/2?
Is it just -22?
Yes. Okay, first step.
Mm-hmm.
What about next? You want to attack the fourth root and this. What's the fourth root of x to the -16? Oh, you can rewrite that in exponent form. Just throw it in the denominator, right? Anything radical, we'll just want to throw it in the denominator like this. See that?
Mm-hmm.
Let's toss it in the denominator. What is x to the -16/4? How many x's?
-4.
Yeah, and then the other one will be -9, and then you have x to the -22. These two on the top use the first rule. You can add them up, becomes -13. On the bottom, we have -22. Do we bring the 22 up or the 13 down?
The 22 up.
So how many x's? Final answer.
9.
Yeah, and you're done.
Okay.
Cool.
Mm-hmm.
E is super simple. How many x's do you think we get?
Do you just multiply everything?
Yeah, you do. Whatever that is on a calculator.
Mm,
-1.8, right?
mm-hmm.
Mm, this one's a little bit trickier actually. What's gonna be the attack here? This is what you do. see this negative one? I'm gonna rewrite that as -1, the negative sign. And then
Mm-hmm.
you have x to the power of 1 over 2 cubed. And then what's 1.2 as a fraction? That's -1 and 2 over 10, right?
Mm-hmm.
That's that gonna be 10 times 1, 12 over 10. That's 6 over 5, yeah? And then you have
Mm-hmm.
this to the power of -6 over 5, like that. And -1 cubed is just -1 still. X to the 1 over 2 times 3 is x to the 3 over 2. So now we've dealt with the first bracket. And now we're going to deal with the second bracket. So you get this times this, x to the -18 over 10. The -1 to the power of that is still negative. And then you can finally throw this in the denominator. You would get x to the whatever that is, 9 over 5. Yeah, cool.
Mm-hmm.
Okay, tell me, what do we do first in f? What do we attack?
The brackets.
Yeah, how many y's for the first one?
-6.
What about on the bottom?
You get x to the power of -6 and y to the power of -2.
That's good, exactly. What's the square root of x6? Well, square root just means to the divided by 2, exponent divided by 2. You see that? Square root of x6 is just going to be 6 over 2. It's x3. In fact, whenever you see a square root of anything, it's always going to have, for example, a square root of x100 is going to be x50. Just simply divide the exponent by 2. Okay? Whenever you take
Okay.
a square root, just divide the exponent by 2. What's the square root of y to the -6?
-3.
Yeah. And then we have x -6, y -2. Bring the -6 upstairs, bring the -3 downstairs. So for the x, how many x's do you get up top?
X to the power of 9.
What about on the bottom?
Y to the power of 1.
Yeah, and you're done.
Mm-hmm.
Let's see what else they got for us. These guys are not looking that bad. Yeah, the only way to like get better at these things is just keep going in head first. And eventually you'll know exactly what to do. Like for example, like here, I can tell you the first thing to do would be just to open the brackets up in the first question and then group up the like terms, right? In B, the first thing to do would be to toss this bracket into the denominator so that this exponent becomes positive. Open the brackets and then collect like terms. Let's look at A. If you were to open the first bracket, what do you get?
-27x to the power of 6, and then y to the power of 3.
So it's going to be -3 cubed, okay? x6, y3 from the first bracket. And from the other bracket, you get -3 squared, x -6, y squared, yeah?
Mm-hmm.
So notice we have -3 here, -3 here. How many -3s do we have in total? We had 3 from the
5.
first, 5. How many x's do we have in total?
Just one.
What's 6 plus negative 6?
0.
0, right? What's anything to the power of 0?
It's a 1.
Yeah, so this thing becomes a 1. How many y's do we have?
5.
Yeah, and you're done. Okay,
That's it.
that's it. Yeah, that is literally it. B is also going to be very simple. Step 1, we don't like negative exponents. We're going to toss it into the denominator. Toss the entire thing because that negative exponent applies to entire thing in there. The actual denominator, we can't do anything with it. Now, if you open this bracket, what do you get?
Um, 5a to the power of -2, and then b to the power of 4.
Good, but not good enough. The 2 also applies to the 5, right?
Mm-hmm.
The exponent applies to every element inside, so it's going to be 5 to the 2, a to the -2, b to the 4. And then 125, you can leave it as it is, but I would rewrite it as 5 cubed because I already have a 5 here,
Mm-hmm.
right? Here's a quick table of cubes. 2 cubed is 8. 3 cubed is 27. What's 4 cubed? 64. And 5 cubed is 125, yeah?
Mm-hmm.
6 cubed is 36 times 6. Look at this. How do you do this, right? I'm gonna rewrite this as 30 because you can do this in your head like that. Then we're gonna FOIL it. 30 times 6 is 180. 6 times 6 is 36. So this becomes 216. You see that?
Mm-hmm.
Like a lot of these are very similar. Like 7 cubed would be 7 times 49. And then you can rewrite that 49 as 50 minus 1. 7 times 50 is 350 because 7 times 5 is 35 minus 1. Minus 7, sorry, it becomes 343, right? You can use like this trick anyways. You don't have to remember all of these guys. It would be helpful to know at least up to 5. 5 cubed is 125. Then we have a5, b minus 3. So how many 5s do I have in the total? In total on the denominator here?
5 to the power of 5.
Yeah, how many a's?
3.
Yeah. How many b's?
1.
Yeah, and you're done. Okay.
Mm-hmm.
Was it difficult?
Nope.
So just remember this one little tiny detail. The cubed or the square, whatever the exponent is, it's gonna apply to everything inside. Okay, so it also applies to 5. That's why it's 5 squared here. Mm, okay, this is as hard as it's gonna get. Um, so it's honestly not that bad. Like here, look at this, right? We always want to kill the brackets first. That's always going to be step 1. So forget about the 5th root on the outside. Step 1, we're going to open both of these brackets, okay?
Mm-hmm.
So I get 5th root of 1024. What do we get for the first bracket?
X to the power of 1.
X to the power negative 10.
Oh, okay.
How'd you get a 1?
I don't know.
Negative 1 times 10, negative 10. What about on the bottom? Open that bracket in the denominator.
2 to the power of 5.
Right. I
And
mean,
x to the power of -15.
right. Okay, like that. Next thing to do would be to plug this in a calculator. Can you tell me what that is? 1024 divided by 25 to the power 5.
It's 32.
It's 32, cool. So we have 32, and then the negative 15, we're going to toss it upstairs. It's going to become positive 5. And now this fifth root applies to both the 32 as well as the 5, yeah?
Mm-hmm.
To find the fifth root of 32, you'd plug 32 to the power of 1 divided by 5 on the calculator, which should give you a 2. What's the fifth root of x5?
Is it just x?
Yes. So the answer for all this junk is just 2x.
Okay.
Cleans up nicely, right? D is going to be the same idea. We're going to apply this 1 over 3 to everything. So we get 8 to the 1 over 3. How many x's?
X to the power of 2.
Yeah, what about y?
Y is just -1.
Yes. And on the bottom, you get 2 cubed, x cubed, y cubed. Notice how the 2 also gets the cube, okay?
Mm-hmm.
8 to the power of 1 over 3, that's simply a 2. That's the cube root of 8, which is a 2. This x squared, I'm going to toss it down. It's going to become x to the 1. This y to the -1, we're going to toss it downstairs as well. How many y's do we get on the bottom?
You get 2.
No, you don't get to. Try again. -1, we're taking the
Oh, you
negative.
get 4.
You get 4, yes. And now this is 2 to the 1. We can also toss this downstairs. We would get just a 1 on top. How many 2's do we get if we toss this here?
2.
Yeah. So 2 to the 2, x1, y4. We know 2 squared is a 4, so you can rewrite that as a 4. And you're done. That is pretty much it. Cool.
Mm-hmm.
Difficult?
No.
In school, do you have a language class?
Yes.
Which,
French.
interesting. How are you in that?
I think I'm okay.
I took French as well when I was maybe about your
Did you
age.
like it?
Yeah, I mean, what's happened with me though, unfortunately, is what happens with a lot of people is that I didn't keep up with it, so I've kind of forgotten most of it, unfortunately. It's good to know a different language for sure, especially French. Well, I'm in Ottawa, which is a bilingual city. Yeah, French is good.
Mm-hmm.
I don't know if this is the same in your city. Like over here, everything is both in English as well as French. You see all the signs and stuff? Like everything, like stop sign, it says stop, but directly underneath it says arrête, which is French for stop, right? Not only the signs,
The only French I see here is like on food labels.
okay, okay. Like even when you're like on the train or something, the announcer, he says it in like both languages. It's pretty, but you don't need to know French to live here, but I mean, obviously it'll be helpful. Um,
Mm-hmm.
in fact, down the road, if you ever want to get like a government job, right? If you want to get a
Mm-hmm.
government job, they would prioritize people that are bilingual, especially in Ottawa. And I guess there's a couple of other provinces that are bilingual. I think PEI and yeah.
I was
Mm.
actually put in Mandarin and then I had to like switch to French.
Oh my God, that is so hard. I actually also took Mandarin, and I didn't remember anything. Actually, French, I remember some things. Mandarin, I don't remember anything at all.
It's like Mandarin is like a different like alphabet than
Yeah.
like French. You just use like English.
It's such a difficult language actually. The number of characters they have is absurd. Like French, English, whatever, we have like 26 odd.
Even the numbers look weird.
I think China, like the Mandarin itself, has like over 2,000 unique characters, I think, which is like, what? How do you keep track of all that? But the good thing about that, I don't know if it's a good thing, but most people in the world speak Mandarin, if you think about it. A lot of people speak English, obviously, but the second most is has to be Mandarin, I think. Could be Spanish though, because the population of China is almost 2 billion by themselves.
Yeah, but most of the Mandarin isn't even the same.
Right. They have different dialects and yeah, depends on which province you're from in China. It's gonna be a little bit difficult. I also learned something called Cantonese, which is like Mandarin, but again, don't remember any of it. But I remember like we had to learn both of these guys, and I hated both of these. Very difficult, especially if you're not born there. French is okay though. French is more learnable. Anyways, let's look at this question. What are we trying to do here? We're trying to simplify. I mean, that's the only thing we could do. Look at the bottom. We have t squared minus 7t minus 18. How do we factor this?
Do you use man?
Yeah, use man because it's a quadratic trinomial. What are the numbers? It's going to multiply to negative 18. It's going to add to negative 7. No? Only so many things multiply to 18. There's just three I can think of. 1 and 18. That would never add up to negative 9. What's the other one? What multiplies to 18?
2 and 6.
2 and 6 is 12. 2 and 9, right?
Mm-hmm.
Can that add up to negative 7?
No.
Yes, it can. Negative 9, positive 2.
Oh.
Right? We're actually looking at plus minus 2 and plus minus 9. Does any variation of that add up to negative 7? And yes, it does, if you could do negative 9 and 2. Okay? And because
Mm-hmm.
the leading coefficient here in the denominator is a 1, you can just do this in one shortcut step. It's going to be straight up t minus 9 and t plus 2. You can use this straight up method as long as the leading coefficient in front of the t squared is a 1. Okay? Plus
Okay.
6 over t plus 2. What's next?
Could you add the 5 and 6?
Um, Good question, right? No, you can't because think about it this way. You have 1 over 3 times 2, and then the other one, let's say you have 2 over 3, right? Can you add the 1 and 2? No, you can't because they don't have the same denominators. Okay?
Mm-hmm.
In this case, you want to multiply this by 2 and this by 2, and now you can add 1 and 4. So the answer is going to be 5 over 6. In order to add the numerators, the denominators have to be the same, okay? You gotta take the LCD, the lowest common denominator. Just like it applies to numbers, it's gonna apply to letters or any variations of these things. This guy, the 6 over t plus 2, is lacking t minus 9. Just like how you multiply this 2 by 3 to get a 6, yeah? I'm gonna
Mm-hmm.
multiply by what it's lacking, and once you do it in the bottom, you have to do it in the top as well, just like we did it here. Cool.
Uh-huh.
And 6t minus 9, if you open that bracket, what do you get?
Do you multiply?
Yeah, multiply. If you open that bracket, what do you get? You just FOIL it.
16 minus 54.
Yeah, minus 54. And now you can combine this 5 with this numerator because the denominators are the same. So it's going to become one big t minus 9 t plus 2. So you have 5 minus 54, which is negative 49, plus 6t. And on the bottom, you have t minus 9 t plus 2, and you are done. You can't go any further than this. Okay.
Okay.
Easy as that. So yeah, you just need to take the whenever you're this only applies to when you're adding though.
Mm-hmm.
Where did that go? Yeah, right here. What about when you're multiplying? Do you need to take the LCD when you're multiplying?
No.
No, you don't. Only adding and subtracting LCD. Multiplication, division, no need. Um, Here, before we do this, let's quick question here. This denominator here was t minus, what was it? T minus 9, t plus 2, yeah?
Mm-hmm.
The other one is t plus 2. What are the restrictions for t? What can t not be? If t were to be something, you would get a 0 in the denominator. There's two restrictions for t in this question.
T can't be 9 or negative 2.
Right, and that's it. Here, tell me, what does this factor out to? The first one. And it's always easier than you think, right? It's going to multiply to negative 12. It's going to add up to negative 1. What are the numbers?
Negative 3 and 4.
Um, that works, right? No, actually, does that work? Think about it. Negative 3 and 4. Does that add up to negative 1? That right now is gonna add up to positive, but we need it to add up to negative 1.
So negative 4 and 3.
Yeah, negative 4 and positive 3, right? And because of the fact that it's the leading coefficient is 1, you can straight up write this as x plus 3, x minus 4, okay?
Mm-hmm.
Times. Can we factor out anything in the numerator here?
No.
Yes, you can. You can pull out a 2. What are you left with?
X minus 4.
Yeah. And on the bottom, we have to man this as well. It's gonna add up to, what does it multiply to? What does it add up to?
It adds up to 4 and multiplies to 4.
It adds up to negative
Negative
4.
4.
What are the numbers? There's only one thing multiplies to 4.
Negative 2, negative 2.
Yeah. And then you can straight up write this as x minus 2, x minus 2, okay?
Mm-hmm.
And now this is my favorite part. We cancel things out, yay. X minus 2, x minus 2 gone. X minus 4, x minus 4 gone. And that is as far as you can go. So the final answer is just going to be the leftovers. We have a 2 left over in the numerator, and we have x plus 3 left over from the first, and x minus 2 left over from the second. We're done, but now we're going to list out the restrictions. Can you tell me what can't x be in this question?
Negative 3 and positive 2.
You're missing one. What about this guy?
Oh, 4.
4. Just because it got canceled out doesn't mean it doesn't have it does. Because if that were to be 4, we could not go to this second step to begin with. So that
Mm-hmm.
also counts as a restriction, okay? Even if you
Okay.
canceled it out. Um, let's look at this. The 4x, you can't really do anything. How do you factor the denominator?
You use man.
You use man, right? Man keeps coming again and again and again. Get used to man. Man is your friend. What does it multiply to? What does it add up to?
It multiplies to 36 and adds up to 13.
What are the numbers? We go to what multiplies to 36. 1 and 36 would never add up to 13, automatically out.
Is
2
it
and, yeah,
9 and 4?
it is 9 and 4, that's right. But the fact that in this question, the leading coefficient is not a 1 means we can't shortcut our way into this, okay?
Mm-hmm.
So what we need to do is we need to go old school long way. The long way also works for the shortcut type questions. So we're going to rewrite the 13x as 6x squared plus 9x plus 4x plus 6. What can we pull out from the first two terms?
3x.
Oh, yeah. What are you left with in the bracket?
2x plus 3.
Right. What about from the next two?
A 2.
Yeah. What are you left with in the bracket?
2x plus 3.
Yeah. Both the brackets should be the same, and then you can combine them into 3x plus 2 and then times 2x plus 3. Okay, that's how you factor out that denominator. Now let's move on to the next term. We have minus 3x. Okay, now we're subtracting. That means this is going to be some LCD mumbo jumbo. What is this factor out? How do you factor this? Can we factor this?
Can you use difference of squares?
Yeah, you can. Good. What does it factor out to if you do?
Um, 2x squared minus 3, and then 2x squared plus 3.
2x minus 3. Because you can write this as 2x squared minus 3 squared. It's going to be a minus b, so 2x minus 3, no squared.
Okay.
All right, now we're trying to subtract it. What's gonna be the LCD? What do you think?
How do you find that?
Let's do a quick little experiment. Let's say we have 1 over 2 times 3 minus 1 over 4 times 3. Okay, they
Mm-hmm.
both have a 3, so that's gonna be one of the denominators. But then they both need a 4 and a 2. So that means you need to multiply this by the 2, okay? And you need to multiply this by a 4. You understand this?
For the second one, wouldn't you just multiply by 1?
Yeah, you would. That's right. But for the sake of this example, because we have 3 different terms, this also works, okay? Yeah, you don't
Okay.
need to multiply this by 2, but you'll see why in this question. So they both have 2x plus 3. So that's going to be the common thing. We don't need to multiply anything by 2x plus 3. But the first term is lacking the 2x minus 3 guy, right? Like that.
Mm-hmm.
Multiplied on the bottom, multiplied on the top. And the second guy, what is he lacking? He's lacking the 3x plus 2, right? The 2x plus 3 and 3x plus 2, they're not the same thing. So I need to multiply that by 3x plus 2 on the bottom and on the top like that. Okay?
Okay.
And then we open the brackets. What's 4x times 2x minus 3? What do you get if you open this bracket?
8x squared
Yeah,
minus 12.
just 12?
12x.
12x, right? And then you have this entire mumbo jumbo on the bottom. What about when you open this bracket?
9x squared plus 6x.
Plus 6x. But the fact that we're subtracting, yeah? See,
Mm-hmm.
whenever you're subtracting, you make sure to put this in a bracket. So we have minus 9x squared plus 6x here. And then in the denominator, we're going to have all three of those guys, the common denominator, 3x plus 2, 2x plus 3, and 2x minus 3. Okay?
Mm-hmm.
Okay, now we have 8x squared minus 9x squared. That's just going to be negative x squared. We have negative 12x minus positive 6x. That's going to be negative 18x all over this denominator. And you can pull out an x on the top and you'll be left with negative x minus 18 and all over all three of these guys. Okay? And that's going to be the
Mm-hmm.
final answer. What are the restrictions here? What can x be?
X can't be negative 2 over 3.
Yeah.
Or negative 3 over 2.
Anything else?
And then just 3 over 2.
Yeah. And you're done. Okay.
Mm-hmm.
Let's see if there's any like fun type questions. There's this one. This is such a corny question. I'll read this.
Bonnie and Clyde.
Yeah, so if she's away, then heartache. Yikes. Okay. If Bonnie is absent, by how much does Clyde's pain increase between day n and day n plus 1?
You can measure like heartache.
No, you can't. This is just this is a made up math question. What does that mean? What do you think? So for A, what you need to do is you need to find h of n. Well, that's already given in the question. That's 2n plus 1 cubed, yeah?
Mm-hmm.
And we need to find something called h of n plus 1. How do we do that? This is going to be a little bit tricky. The trick is this. You see this n?
Mm-hmm.
We're going to replace that with n plus 1. So we would get bracket 2, but instead of just n, the heartache at n plus 1 is going to be like that. Plus 1 cubed. See that?
Uh-huh.
Like for example, if you wanted to find h of 4, you simply replace that n with a 4. If you want to find h of a, you'd replace that n with an a. If you want to find h of a tree, doesn't make sense. Well, this question doesn't make much sense either. You'll simply replace that n with a tree. Okay, that's the idea. So that's why when we're trying to find n plus 1, you want to replace that n with n plus 1. And now we're trying to find the difference in pain, right? So we need to do
Mm-hmm.
h of n plus 1 minus h of n. So this will give us 2n plus 1 cubed minus 2n plus 1 cubed. And there we go. That's the answer. For B, day 6, then on day 5, you just find h of 5 and h of 6. Look at this. How do you find h of 5? Well, just replace that n with a 5. So you have 2 times 5 plus 1 cubed. That's 11 cubed. And h of 6 is just going to be 2 times 6 plus 1 cubed. What's that? 13 cubed, right? Yeah. So the difference in pain between day 5 and day 6 is simply 13 cubed minus 11 cubed. You can plug that in a calculator for part B, okay?
Mm-hmm.
Let's say, just quickly hide this. Let's say we have some function f of x equals x squared plus 1. What is f of 1 going to be? You simply replace that x with a 1. So it's going to be 1 squared plus 1, which is a 2.
It's 2.
What is f of a going to be? Well, you simply replace that x with an a. It's just going to be a squared plus 1. What is f of 3 going to be? It's going to be 3 squared plus 1. You just replace that x with what's in this bracket, okay?
Okay.
Using this logic, can you tell me what f of x plus 1 is going to be? You simply replace that x with what's in the bracket. You would get x plus 1 squared plus 1, like that.
Mm-hmm.
See that? What's f of 2a minus b gonna be? Well, you're gonna replace that x with 2a minus b, so you get 2a minus b squared plus 1, like that.
Okay.
Okay, this one is a little bit important. Why is it important? We'll see next time. All right, let's call it.
All right. Thank you.
Bye-bye.